Request for nomenclature. Fall 21, test 2, part 3. Big Bad Bicyclo. I got a question for you that illustrates old rules mixed with new rules. Why are these carbons special? Those are bridge heads. So biggest bridge is on the bottom. How many carbons between the bridge heads and the bottom? 1, 2, 3, 4, 5, 6, 7. That goes first, biggest number. That's the smallest bridge, it goes last, 2. Middle size bridge, 1, 2, 3, 4, 5. 7 plus 5 plus 2 is 14, plus 2 dots, 16. Hexadeck, leave room for a number. We don't know the number yet. Somebody thinks they do. Like 3. You like 3? Your two choices for one you can't, the bicycle rules never go away. So your choices are 1 here in green or 2 here in blue. Advantage of, not a 2 there, sorry, 1 there. There's your 2 ones, okay? But you might say because there's a group on 1, it works better for blue. You're forgetting the new rule, alkenes are more important than groups. So if you have an alkene in the rings, you need that to be the lowest number, so blue does win over green, right? No green, go blue. I always love saying that, I'm sorry. Hope no Sparty fans out there. Okay, there's a lot of Sparty fans out there. We got one right here.
What if you have double play on 7? If you have double.
Sorry, say it again.
What if you have 2 play on 7, for example, like alkene on 7.
Alkene on 7?
Yeah, let's say 8.
If there was a double bond there.
Yes.
Between 7 and 6.
Yes.
Which way do you go? Then number 1 would decide it. You'd have a double bond the same distance from this bridgehead as this bridgehead. Great question. Now that I see your question, I love it. Okay. He's saying, what would happen if you had 2 double bonds? And yes, they both would start on 3, whether you started green or blue, right? Now your decision process says, well, there's a group on 1 in blue. There's not a group on 1 in green. Blue still wins. But that was a hypothetical for a different question, right? Okay. And the ene is now between 3 and 4. So there you go. Groups. One starts with a P, one starts with an F. P for phenyl, F for floral. Which one's alphabetically first? The floral. And it's a group on a group. A fluoro is on an allele. How does that work? You had the laugh that says, how do you expect me to know? Okay. All right, now how does it work? The part attached gets named last. So allele is attached to carbon 1, agreed? So it's at the end. And carbon 1 of the allele group is the one attached. So in the group, this is carbon 1 of the group. 1, where's the double bond? 2, you don't have to say that, alleles got that. 3 has the floral, that's important, 3 floral. Starts with F, as promised. And that's on carbon number what of the ring? 1. And then on carbon 4, there's a different group, and it goes in parentheses. The part attached to carbon 4 is an ethyl group. Do you agree? It gets at the end. It gets named at the end. What's attached to that? What's that thing over here? A phenyl. What carbon number is it on? Remember, carbon 1 of the ethyl group is the one attached to 4, and carbon 2 of the ethyl group has the phenyl. Okay? Do you want me to put those in colors to show you what they mean? 3 and 2. It's a very fancy 2. 1, 2. 1, 2, 3. Orange is numbers for the group only. Has nothing to do with hexadecene, correct? Yeah. And you almost got half credit now. Congratulations. Stereo centers and double bond geometries. Oh, this must have been a 5-pointer, was it?
Yeah.
Yeah, because it's got 2 double bonds that exhibit geometric isomerism. What? What's the answer? The answer to that is easy. I mean, that is the answer. Okay, easy. That's the isomers that are possible. You better tell me which ones you got. And there's 2 stereo centers. 4. I call those 4 stereo elements. You don't need to know that. We'll put the stereo elements big right up on top. There's a stereo center on 1. We need to do that. There's a stereo center on 9. Oh. One of the stereo elements is inside of a group. See the group with the fluoro on it? Isn't the E part of a double bond that's in the group? So where does that E go? In the group name. How do you know this is a Z group? Here's your steps. Fill in the missing H's if they are there, and yes, they're both there. Cut the double bond in half. Assign priorities 1 and 2 to each side. One's on the same side, you say Z. So I'm sneaking it in right here. You sneak it in after the dash. Z, 3 dash Z dash, fluoroallyl. Okay. And since we're on stereo centers, let's do the one on 3. Same protocol. Cut it in half. Put on missing H's if there are any, and there are. Always a 2 for the H and a 1 for a carbon. CH2 that goes to a CH2 that goes to a phenyl beats a CH2 that goes to a CH2 that goes to a CH2. And this one's on opposite side, E. And you tell me that's the one on carbon 3, it's E. Stereo centers. How many have we done? We've done hundreds. Purple. 4 for an H over here. Which one's the 1? There's like 3 CH2s. This one hits stuff first, doesn't it? CH2, CH2, stuff. This one is 5 CH2s, then stuff, and this one is 1, 2, 3, 4, 5. Nope, not 5. The 5th one has stuff. 4 CH2s, then stuff. We talk weird in this course, don't we? Mom, your mom's at home listening to the video. What do you mean 4 CH2s and then stuff? Okay, and this one had the 5 CH2s and then stuff. And oh, luckily the 4 is on a dash, so 1, 2, 3 gives us the answer directly, and it is clockwise. R. Yeah. And then 9 is a stereo set. 9 is a stereo. That was 9. Ah! Sorry. Less sound effects, Dr. Wood. Okay, 1. Start over. We got fat yellow. We don't use it enough. It's growing on me though. I think the 1 is here. CH2 stuff. No.
No, in the fluorine.
I'm liking that fluorine stuff better. Yeah. They're kind of tied, but not really, right? They both are CH2, then a C double C. CH2, then a C double C. After the C double C though, what's the heaviest thing on the end, this end of C double C? Fluorine. What's the heaviest on this end of the C double C? Not fluorine. C. So we're lucky. And 4 is a dash again. Oh man, merciful. That's clockwise as well, isn't it? The only way I can use yellow is to make it big and fat. Okay. CMI. Done.